Welcome, class. Thermodynamics. Let's go. In chemistry, under Chem 130.1, we talked about a formula that are confusing students in thermodynamics, and it's so easy. And that is, in chemistry, we have that change in U is equals to Q plus W. There's something you need to know, please. This formula relates to that of chemistry, but we have another formula students normally have issue with, which is Q minus W. Now, this first formula is that of the chemistry. That's why I wrote in chemistry. Why this one is in physics. Now, I want to make a quick introduction about these two formulas. Look at it very well and observe it very well. Now, the thing you can observe here is that the first one, we have that change in U is equals to Q plus W. I want you to know something, please. Change in U is the internal energy. Is the internal energy. The internal energy. While the Q is the heat. Is the heat added or removed. While the W is the work. I want you to know something. Under this system point of view, I want to first explain these two formulas, what it relates and what it means. So now you can see, like I said, under chemistry we have change in U is equals to Q plus W. In physics we have Q minus W. Now, the most important thing, how I remember this is, I use this thing I call boom. Now, if you're considering this formula, that of the chemistry, we are using both. That means that work done by the system, and then work done on the system. Now, that is why I'm using both, for me to remember it. So it simply means if the work done is by the system, my work, if I'm using this formula, my work is negative. But if work is done on the system, it means that my work is positive. Are you seeing it? Now, this is under chemistry if you're using this formula. But if you're using this formula in physics, that change in U is equals to Q minus W, that means your bow, which is work done by the system, that means that this will not interchange to the clause. While work done on the system, meaning that your W, which is work done on the system, will not be what? Negative. So please note the two formula is actually very important. Like I said, the two formula is the only thing that separates them is the sign of their work. So if work is done by the system or work is done on the system, so please, because sometimes you will see someone say so this and they use this formula, they will not say, you fail it. What about this? So please know the difference. This is introduction. And like I said, in why the formula is somehow like this is, in chemistry, they are considering the system point of view, while in physics, we are considering the viewpoint of the system. In chemistry, I will take it again. This is an exam question. In chemistry, they are considering the system point of view. We are considering the system point of view, while in physics is the viewpoint of the system. Now, if this is the system, I want to talk about different types of system. I want to talk about different types of system. Follow me on this video. Now, a system, we have, of course, we have the open system, we have the closed system, we have the isolated system. And so this is the open, this is the closed, and this is the isolated system. Now, you have to understand this. Under a system, like I said, we have three. We have open, close, and the isolated. In open system, what is actually happening here is that matter can enter, energy can enter. So both energy and matter can actually enter into an open system. But look at what is happening in a closed system actually. Please note this thing very well, because over the time I've asked, students have been asked this and they find it difficult. Now look at what happened in a closed system. Matter cannot enter, but energy can enter into a closed system. While an isolated system, energy cannot enter, heat energy cannot enter, and matter, which is an O2, oxygen, and the rest, cannot enter. So note the different what is actually happening in closed and open system. Now, if this is a system, we want to talk about, if this is a system, the surrounding, this part is called the what? The surrounding. What is covering the system is the what? The surrounding. And then you have to know something. That's a very important point there, is that in the surrounding, we want to know what is happening using the first law of thermodynamics. Now, there is a series of videos I'm going to release on this series. Please endeavor to follow up. This is just the part 1 of the video.